Hello and welcome. Today, we will explore the key concepts of Unit 2, Environmental Science and Energy Transition. This session will focus on understanding environmental challenges, energy transition strategies, and their relevance to sustainability management. By the end, you will be able to critically evaluate these issues and apply strategic insights in line with the learning outcomes of the OTHM Level 7 Diploma in Environmental and Sustainability Management. The assignment involves a critical essay of 4,500 words. It requires a pass or fail grading based on meeting all assessment criteria. Harvard referencing is mandatory. The scenario is a policy review for a climate change charity. The essay is structured into 6 sections, each addressing different aspects of environmental science. Section 1 focuses on the carbon cycle and the Intergovernmental Panel on Climate Change. It differentiates between Scope 1, 2, and 3 emissions. The section explains the carbon cycle and the Anthropocene. It compares carbon footprint with life cycle assessment. A summary of the IPCC 6th Assessment Report is included. To approach LO1, use the IPCC AR6 summary for policymakers. Define Scope 1 to 3 using the GHG protocol. Include a diagram of the carbon cycle. Compare carbon accounting versus life cycle assessment. Explain historical energy transitions from coal to oil to renewables. Section 2 covers renewable energy technologies. It explains photovoltaic, concentrated solar power, and both onshore and offshore wind. Hydroelectric, tidal, wave, and geothermal energies are also discussed. The environmental impacts of these technologies are analyzed. The natural setting of the UK and its suitability for these technologies are evaluated. Use UK Department for Energy Security data to approach LO2. Compare the impacts of offshore versus onshore wind. Utilize National Grid ESO reports. Discuss intermittency and land use conflicts. Critically evaluate rather than just describe the technologies. Section 3 delves into non-renewable alternatives and political sensitivities. It discusses carbon capture and storage and biomass principles. The debate on the renewability of biomass is highlighted. Nuclear power and waste management are examined. The section also covers hydrogen colors and associated risks. Use data from the IEA and World Nuclear Association for LO3. Discuss strategies of China and oil-producing states on carbon capture and storage. Compare green versus blue hydrogen. Analyze geopolitical energy security implications. Critically assess environmental and political issues. Section 4 focuses on storage, grids, and the circular economy. It compares centralized versus distributed grids. Battery storage options like lithium-ion and pumped hydro are explored. The life cycle assessment of lithium batteries is discussed. The circular economy for rare materials is also covered. Use IEA energy storage reports for approaching LO4. Discuss the challenges of UK grid transition. Apply the life cycle assessment framework. Explain the recycling and rare earth supply chain risks. Explore the transition to a circular economy for rare materials. Section 5 defines the energy trilemma, which includes security, affordability, and sustainability. It assesses national and international renewable policies. The section critically evaluates international collaboration. One policy is selected for critique, highlighting its strengths and weaknesses. Realistic improvements backed by evidence are proposed. Use the World Energy Council Trilemma framework for LO5. Select a policy like the UK Net Zero Strategy or Paris Agreement. Evaluate measurable outcomes. Propose realistic improvements backed by evidence. Critically assess the policy's strengths and weaknesses. Several academic and policy sources are recommended. The IPCC 6th Assessment Report is a key source. The International Energy Agency provides valuable data. The UK government energy policy offers insights into national strategies. The World Energy Council and GHG Protocol are also essential resources. Level 7 expectations require evaluation and critical assessment. Descriptive analysis is not sufficient. Integration of policy, physics, technology, and economics is essential. Use case studies and real data to support arguments. Demonstrate a strategic understanding of the energy transition. Carbon accounting and life cycle assessment are distinct concepts. Carbon accounting focuses on emissions tracking. Life cycle assessment evaluates environmental impacts from cradle to grave. Both approaches are crucial for comprehensive analysis. Understanding their differences enhances environmental strategy development. Energy transitions have evolved historically. The shift from coal to oil marked a significant change. Renewables are now at the forefront of energy strategies. Understanding these transitions is vital for future planning. Historical context provides insights into current energy challenges. Evaluating renewable technologies involves environmental and economic analysis. Photovoltaic and wind energy have distinct impacts. Hydroelectric and geothermal offer unique advantages. Critical evaluation goes beyond description. A comprehensive approach ensures sustainable energy solutions. This is the conclusion of the video. Questions? Reach out via WhatsApp at 074-843-61688. Our team is always happy to help. Thank you for your attention and see you at the next session.